All right, good morning, everybody. Oh, just awful.
Come on,
So
it's 11:30. I mean, this isn't first thing. Come on. Good morning, everyone. Oh, that's better. All right.
Very good. So we're going to go through a lot of stuff today. Is the code on the slide here, buddy? The code that you need for your own edification is here. Grab that. Take a photo of that right now. We're going to go through a lot of stuff, and we don't expect you to follow along and see everything.
Oh.
But just grab that code, right? Keep that code for your own reference for later. We're going to go through an absolute, just crazy amount of stuff. Because we have very little time, we're going to go a little faster than we normally might have. Just a little. And who are we, you may ask? Well, that's a good question. I'm Josh. This is Mark. Hi, Mark.
Hi, Josh.
We're online. If you have questions, we're on Twitter. We're happy to answer questions. Our Twitter addresses are there. The coordinates are there. How many of you are on Twitter? Just curious. It's 2017. Twitter. Okay, the rest of you, get on it. It's the new IRC. It's a great place to be. It's where all the software developers that drive the software that you use in your businesses are. And if you want to exchange, you should be on there. We're happy to engage. What about email? How many of you are using email? Email. Anybody? Okay, well, there you are. Find us there. And we work at Pivotal. And this art is by one of our teammates named Ashley McNamara. And it's awesome. And so we look at those logos. Aren't they great? Like Simpsons-style logos. Okay, fine. Anyway, we work at Pivotal, and we care very much about all these open source projects.
Just so you know, that's the best part of the presentation.
That is it. So, it's all downhill from here.
Come on.
Yeah. We care very much about the open source projects. We care about we have a lot of great open source projects at Pivotal. We've got Spring. How many of you are using Spring? Just curious. What about Cloud Foundry? How many of you are using Cloud Foundry? Okay, good. So good, many of you. We have other projects like Apache Tomcat. How many of you have ever used Apache Tomcat? Apache Tomcat. Okay. What about RabbitMQ? Good stuff. So a lot of good open source projects, and we care about that. But at the end of the day, what we care most of all about is agility. How quickly can an organization take an idea from concept to cache, right? From the very idea to delivering it into production. And we see that a lot of organizations struggle with that. And so one thing that's helped these organizations go faster and to move ideas from idea all the way to production safely and capably is this idea of microservices. You decompose your application into smaller batches of work to enable smaller teams to reduce the cost of synchronization in the organization. And the microservices architecture has a lot of benefits. One thing that people struggle with, of course, is the complexity that you get when you build a distributed system. And while we've got some great technology in the Spring sort of portfolio, including Spring Boot and Spring Cloud to address a lot of that, one thing that we've seen sort of lacking and needing support is how do we deal with services that have lots of data? Like if you're moving lots of data across the network, that implies input and output, I/O, right? And that input and output is expensive, especially as you start to scale out. And especially as you have large amounts of it, right? And so what we look to is some way to move data across input and output buffers more efficiently, more capably. And so this is not a new problem, of course. In the sort of base operating system primitives and the C standard library and most operating systems, you've got support for asynchronous I/O. And that got baked into the JDK and JDK 1.4, right, with the Java NIO support and so on. And in the Java community, since then, since JDK 1.4, more than 15 years ago, we've seen different companies struggle to find ways to integrate that low-level asynchronous I/O into their programming model. But remember, what we're talking about here is input and output that happens asynchronously. Events get fired when you can do things with the data. So you have to think about the possibility that values that you read in your system aren't going to be there when you ask for them, right? This is actually the truth of the underlying systems, if you think about it. We are used to dealing with Java I/O input stream and output stream, but these are actually lies. They're abstractions. By default, these input and output metaphors underneath are asynchronous, right? So we deal with them in synchronous style in JDK I/O, but in NIO, we can go back to the sort of original approach. The question then becomes, I've got these values, and they're going to come at me asynchronously, and I need some way to model that, to work with them, and to think about these values in my code. In the JDK, we have three out of the four sort of quadrants of return values well defined. If I want to return a single synchronous value from a method, I say t void, or t foo, where foo is the name of the method. If I want to return a collection of values synchronously, I can say a collection of t, right? If I want to say that I have a single value that's going to be returned asynchronously, I say completable future of t. So I'll get a value when it's available, and I get a note, I get a callback using the completable future. What we are lacking is that fourth quadrant, multiple values returned asynchronously, right? A potentially unlimited amount of values that aren't going to be available right now. And so for this, the different organizations in the Java ecosystem have looked to find a way to find an abstraction to define this. And different companies have done some great stuff, right? Lightbend, which was born as a type safe. They have akka. The folks at Microsoft Research, they did the RX extensions for .NET, and that got turned into something called RX Java over at Netflix. Red Hat have a project called Vertex, which interestingly started at VMware and SpringSource years ago, but it's now a very separate thing back at Red Hat, and it's also got support for this kind of stuff as well. And on the Spring team and the Pivotal side, we've had this thing called Reactor since 2011, and Reactor is our API for modeling this sort of last missing piece, right? All these frameworks solve basically the same problem, or at least at the very heart of it, they solve basically the same problem. And so these different organizations converged upon a very, very lightweight standard. We created a de facto standard called the Reactive Streams Initiative. And the Reactive Streams Initiative is a working sort of effort by these different companies, and others besides, by the way, to define the very essence of what we're trying to do here so that we can support interoperability. At the very heart of this specification is the idea of a publisher. A publisher is a thing that will produce values when they're available, and you can get a callback. You can say, I want to subscribe to the values that come from that publisher. A subscriber can make a subscription. So there's a subscriber, and then there's the object that gets created when that subscriber makes a subscription. That's called a subscription. And then finally, we have a fourth type called a processor. A processor is something that is both a publisher, it produces values, and a subscriber, so it consumes values. So values in, values out. This specification, these four simple interfaces, are the essence of what we need to solve this missing thing, this missing quadrant in the JDK. And in fact, if you look at JDK 9, that basic specification has actually been forked and made part of JDK 9 itself, right? As we just saw in the previous discussion. So in JDK 9, we're going to have Java util concurrent flow based on the work from this Reactive Streams initiative. So these four interfaces, they're very simple. Most of them just have a few methods. Could we just implement that ourselves? Of course not, right? Writing code that does the right thing here efficiently is extraordinarily difficult. And even if you did do that, building operators that you can use on top of that becomes difficult, right? I don't want just to be able to say, I want to subscribe to values. I want to be able to operate over streams of values just like I could collections. And so here, we still have a lot of use for projects like Reactor, right? Reactor provides operators on top of the Reactive Streams initiative. So it provides actually two specializations of publisher. One is called a mono. It's a publisher that produces 1 or 0 values. The other specialization is called a flux. Got flux. A flux is a publisher that produces 0 to n values, where n is like infinite, right? So you have this very, very high-level sort of DSL for building systems that work with potentially unlimited amounts of values. We can use this to build interesting things, but we still don't have the ability to build a REST API, to do data access, to do all that kind of stuff, do we? So we need something more than that. And so in Spring 5, coming this summer, we're going to have our first reactive web runtime called Spring Web Flux, and we'll talk about that. And you're going to see in the next year, you're going to see us unveiling sort of reactive support in the different Spring ecosystem projects. And so with that in mind, I think we should build an application to talk about it today. What do you think, Mark?
We should.
We want to build a sample application. We don't want to get too deep into the domain model. We just want to have something with which to work, something that we can think about easily. I was thinking about, I was watching a movie the other day. What do you think? Want to do something with movies?
Let's do movies. Movies are fun, right?
Something where we could, imagine we had the domain where we could stream movies over the net.
I'm not sure that'll ever take off.
Now, in English, another word for a movie is a flick.
Right.
So we could stream flicks over the net. We could call it Netflux.
Yeah. I think that should work.
So let's do that. Let's build a new
That doesn't
service,
sound anything like anyone else.
No, there's no way we're going to get sued for that. That's probably fine. It's fine. So we're going to go ahead.
Where should we start?
We should start here at start.spring.io. This is my second favorite place on the internet. It's our second favorite place on the internet. No, I got this.
Okay. I take great delight in...
I think I can do this.
Well, that's interesting. What happened there?
Did you forget to mirror friend of friends?
No, it was mirrored before.
I scared it away.
Oh, that's right. When you done. Never mind.
Okay.
So should be good.
Oh, sweet nectar. Very good. So we're going to build a new application.
Flow
Here.
that up.
Yes.
No.
M, thank you. So we're going to build a new application here at start.spring.io. This is my second favorite place on the internet. Our first favorite place, of course, is production. We care about production. We love production. You should love production. You should bring your friends, your family, your loved ones. It's the happiest place on earth.
Is anyone
It's
here
better than
unfamiliar
Disneyland.
with production?
But if you're not already at production, you can
Sad.
begin your journey here at start.spring.io. If you want for inspiration in the early morning before a cup of tea or coffee, start.spring.io.
Since he switched to a Linux laptop, he's really missed the Mac Zoom. So I tease him every
missed
now
it
and then
so
with my
much.
Mac. So
If your children are restless and can't sleep, start.spring.io.
let's
And if you suffer from a long night of if you suffer from indigestion after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a simple application today, and we're going to take advantage of the support in Spring Boot 2.0. This is the milestone that's coming up. We're going to build a new service, and we're going to call this the what? We want to manage the flicks. We need a service.
right, maybe something like FluxFlix service. Maybe
Yes.
anyone?
Flux, flicks,
Flix,
service. And then we're going to use the reactive web support. We're going to use the reactive. We need a database. We can talk to different data access technologies here using Spring Data. We have a lot of different options here. But these are just some of the auto configurations in Spring Boot 2.0. Spring Data itself supports a larger assortment of different database technologies. We're not going to offer you reactive JPA, for example, because the underlying JDBC support doesn't support reactive programming. So we only offer what makes sense. You don't want to wrap a reactive facade on top of a synchronous JDBC API. You'd get slower performance and a worse, more painful API. It wouldn't make sense either way. So we're going to use the database technologies that make sense. These are all great choices, but I think we should use the MongoDB support, because if you want to lose your data and you want to lose it reactively, there is no better choice. There is no better choice. So we use reactive MongoDB.
Let's do Lombok too.
Let's do Lombok, the Java compile time annotation processor. And then we'll hit generate. I think that'll give us everything we need. Whoa. Desktop. Okay, here we are. So, okay, let's see. So we've just unzipped this here. And we're going to open this up in our IDE. Yeah, doesn't matter which IDE. No? Open? Did you set up?
Yep.
Oh, thank goodness. Okay. Sweet nectar. I'll take some tea. Okay, so what do we got here? Can you see that, my friends?
No, probably not. That's kind of
that's
small.
What about
that's
that?
better.
Can you see that? Okay, so we're going to build a simple application today. And we're going to build something to manage our data, our movies, our flicks. So we're going to create an entity here called movie. What?
I'm trying to get out of everyone's way, but I think I just need to lie down on the thing.
We're going to build a document using Spring Data document here. And we're going to have a primary key like so, right? We'll say @ID, there we are. And these are not JP annotations, these are Spring Data annotations, so they're very convenient. We need what do we want to have? A title and anything else? That's enough, yeah. Now, the right thing to do here normally would be to build some getters and setters and constructors and all that stuff, but I don't have time and I don't care, so I use Lombok. We're going to use that it's a compile time annotation processor. And what it's going to do is it's going to create a getter and setter and a toString method and equals and all that stuff. And now we can write data to the database. So we can use here, again, Spring Data as well. And we can create an object that writes these records to the database for us. It handles the tedious, soul-annihilatingly boring data management functions that we care about. But we don't want to spend too much time doing it, so we do it by convention, by interface. The interface here is going to provide the support that we need. It implies data management functionality. Now, this may seem very familiar to you if you've ever used any of the other sort of Spring Data project. This is the reactive Mongo repository. And the one thing you'll notice is that for the reactive variants of these different repositories, the return values are monos and fluxes. They're not void, they're not like a synchronous return value. Same thing here for the sorting. Where appropriate, we return a flux instead of just the synchronous type. So very similar and yet just a little different, right? You can cognitively cross that chasm quickly, but you don't spend too much time. So now the most important part, right? We want to write some data to the database. We need something that we can use.
We need movies.
We need movies, yeah. So this is audience participation time. Actually, it's Josh figured out how to alt. I moved to Linux and my keyboards are just, my keyboard foo is just off. So
I remapped everything too, just to
yeah, it's all VI. Oh. Okay, and then in VI he uses IntelliJ, which just makes it worse.
Yeah.
So here we are, Alt, Enter. Okay, so we want to save some records into the database despite my incompetence. Let's write some records. So what do we say? We need some
movie titles that are somewhat reactive.
Commando.
What?
Commando, come on. It's always Commando.
Commando, but it has to be reactive. It has to be related to the.
It should have something to do with web flux or fluxes or monos or reactive or.
Back to the
that's
future.
good. That's good.
Very good.
The flux capacitor, right?
Very good option. One of my favorites, our friend Phil Webb.
No kidding. We're so jealous. He came up with the best one.
What is it?
The silence of the lambdas. Yeah, I know. As soon as you hear it, you go, "Oh, why didn't they come up with that?"
So grills.
So good.
Okay. What's it? What is it?
Office Space. Is that what one of them? Office Space.
I'll buy it. I don't.
Yeah, we'll take it. We'll take it.
Okay. What's that? There's an anime with it in the title, with the word flux in the title. Aeon Flux.
Good one.
Thank you. We just did this in Spain, and in Spain they speak Spanish, and in Spanish the word mono means monkey.
Yes.
What was the one that we saw there?
Y tu mono también.
Yes. There we go.
Let's do that. A Cuarón film. Yeah.
And then we also we got 12 monos.
Yeah. Anyone else?
What about
What about Meet the Fluxers?
Meet the Fluxers? Yes. No, Meet the Fluxers. So hungry. Awkward. Okay, so now we've got a title, and we got to create a record. We're going to write a new record to the database here. So new, we're going to say movie repository.save new movie.
By the way, if anyone comes up with additional titles, please shout them out because we'll go back and add them in. This is very important.
It really is the only thing that we care about.
Yeah.
It's the most
after
important.
the graphics. After the graphics.
I mean, everything else is very, very uninteresting. So, okay, so we're going to save some records, and I want to save a record by giving it the title. That looks like it should work, but do you see anything wrong with that?
It's missing something, right?
So in the reactive world, this isn't going to execute unless we subscribe to the result. We have to tell the reactor type that we want to activate the chain of operations here. Just like in Java 8 streams, you need a terminal operation. So we can stream it. That's one way to do it. We can stream that everything's been written, or we can just do a subscribe that's empty. And then what I want to do is, I want to write everything out that gets written. I want to visit everything in the database and subscribe to everything in the database, and I just want to print it out, right? And this should work, I suppose. Seems like it should be very similar and very simple. But this has one particular problem, doesn't it? What's the problem that you see with this besides my key commands? There we are. What do you see?
Oh.
There we are. We're happy. We're good.
Yeah, and that'll work fine the first time, right?
That'll work fine the first time, but what happens if I do again? So this is MongoDB, and a broken clock strikes true at least twice a day.
And there it is.
So maybe even Mongo would save it. Maybe even Mongo would successfully write the data to the database.
You'd hate to count on that.
Not a lot.
There's a chance.
So. I wouldn't bet the business on it, but it might record the data. And if it does, then it's additive. We're going to have the same records over and over again. So what I want to do is I want to delete everything before we then write the data. So we have a clean slate, right? So I'm going to say movie repository.deleteall.block. That's not very nice, is it? I showed that to my girlfriend, and she said, "You're not very smart, are you?" She doesn't think I'm very smart at all when I did that, when I showed her that blocking code. So we have this nice reactive API.
We should use that.
Blocking, right? We need to say, I want to run this after this has been run, but I want it to be done in an event, sort of asynchronous fashion, right? So instead, again, we can use a subscriber here, but we don't want the first callback is a consumer avoid. Well, there's no callback. It's not going to actually emit a value, So we don't need that first value. We don't need that first consumer. There's an overload here that takes a consumer of the items being emitted. That's the one we could call. The second parameter is a consumer that takes an exception if there's any thrown. We don't care about that here because we don't write code that has mistakes, so that's fine. What we care about is having something run at the end of the processing flow, and that third parameter there is a runnable that you can pass in that will do what we want here, right? It's going to be run when the application or when the code is finished executing. Look okay?
Looks better.
Looks better. Okay. Now what?
Well, I mean, we kind of have everything going from the app down, right? So now we kind of need to create our API, create our service API. So that's what I will step up and do next. Look at that. There we go.
Am I in your way
Bring that up
now?
a little bit.
Can you all see that in the bottom there?
No.
Awkward.
Oh.
Let's make that a little.
Yeah. Well, let's zoom in for you so you can get the full benefit. Look at that zoom. Isn't that great?
Oh, it's so nice.
That's so pretty.
Stop teasing me.
Yeah. Brasky Linux doesn't have that.
Can you make the font larger?
Down here?
Yeah.
No.
Okay.
No. Anyway. Okay. We're going to charge on. We'll come back to that. I'll
That's
tease
fine.
him with that, at least for now. So anyway, we need to create our service API. So I'm going to create a service, a component here, and we're going to call this, cleverly enough, FluxFlix service.
Or you can shorten that to
Yeah.
FFS, right? Which of course we all know is short for the very vulgar for Flux sake. It's okay, you can laugh at that, we're adults.
Yeah, and my wife tells me I'm unintentionally funny. So if we say something funny to Josh, he's not very funny either. I mean, to me, he's a comedian, but probably everybody else is probably not that good either. So
My girlfriend says the same thing.
it's not going to get any better. We do take pity laughs, so if it sounds like we wanted it to be funny, just join in, please.
Join in.
So, so let's create our FluxFlix service. So we're going to define a very simple API to start off with. We know we're probably going to want to return all movies, right? So we'll do
Just all?
yeah, let's do that. We'll do an all method. Return, let's see, FluxFlix service. Oh, wait a minute. I'm already in the FluxFlix service. So we'll do a movie repository dot find all, and that's pretty much a straight pass through, right? Piece of cake. That was easy. So let's go on and let's return a mono type of movie. Yeah, by ID.
Single one?
We'll want to be able to search for a particular movie by ID. So I'm going to call this again, cleverly enough, by ID. And we will return, see, I can't even type on my own machine now, so I think it's something you did. Okay, so we'll do a find by ID, and we'll pass it the ID. Again, pretty simple stuff, right? Let's go ahead and crank this up a little bit, because the idea with the streaming service is that it would be really cool if we could keep track of who's streaming what at any given point in time. And of course, if we had a live service, excuse me, if we had a live service, we would probably have this in an in-memory grid where we could track this stuff and just spit it back out, but we don't. We haven't fielded this yet. We're not even to the MVP stage yet. So
we don't have users lined up for this yet?
you know what? Who would buy this service?
Well, that's
One.
There we go.
Oh, that's heartening. Okay, so I think we can make a business model of this, right? Call the VC folks. Yeah. All right. So we're going to kind of roll our own. We're going to generate a flux of type movie event. Oh, mouse event. Oh, did you even define this?
No? So what's the movie event for?
Boy, I have to do everything, don't I? Okay, so we're going to create a movie event. That allows us to keep track of, well, movie events. So who's streaming what when? So let's start off with, let's again do some Lombok magic here. We'll create a class called movie event. And what will we want to track there? Private, like the movie, right?
Yeah.
What movie is being streamed at that point in time and when, right? So let's see, that's good enough for now. That at least gets us in business and up and running to start with. So let's return a flux of type movie event.
This is important.
This is critical.
We're gonna
Naming
watch,
is important.
We're going to stream all of the streams. We're going to have a cross-section of streaming that we're going to then stream so that people can watch it. It's a never-ending stream of streams. We're going to
I love to leave him hanging like this. Actually, I think we should just create the stream and then we could do something with the streams later. Don't you think? Oh, fine. Let's cross the stream.
Yes!
Okay, so let's start with passing in the movie, right? I like to tease him with this a little bit too.
Passing the ID.
No, let's pass the movie.
But
Oh,
you should do
fine.
the work. I want to make it as simple as possible from where we call it.
Gosh, this is just tougher and tougher every time, right?
tougher.
Okay. All right, so how are we going to start with this? Well, let's start by returning, let's start with the ID, right? So we'll pass in the ID, and that gets us back what? A mono, right?
Right.
So let's flat map that.
So we're going to take we're going to take the thing that has one value and turn it into a thing that has multiple values.
Yep.
Hence, flat map too many.
And then we will do a flux.fromStream, and we'll create a stream. We'll generate a stream, if you will, of new movie events based upon our movie. Let's see, what else? And then maybe a date, right? Date. Typing is so important. And then let's delay the elements. Right now, what this will do is just generate a whole bunch of movie events just as fast as it can. Of course, we need to kind of gate that a little bit so we can make something useful of that. So I'm going to delay the elements using duration of seconds to 1. So that gets us down to 1 per second. Very simple, very clean. Now this should work. So do you want to tag out and take it a little step further?
Famous last words.
Well,
okay.
you said earlier we don't make mistakes in our code.
No, we don't make mistakes.
Okay,
You're right.
all
You're right.
So tag, you're it.
Okay. It's so sweaty.
Oh, yeah.
Okay, so we're going to build a new, we've got a service and we're faced with the existential question, something with which we all struggled with at university. If we build a service but we don't have a REST API to be able to access that service, did we actually build the service? And there's no
even have
point.
a service?
So we need to build a REST API, and there's a couple ways we could do this. We could, of course, take the old-fashioned REST controller for a spin. We could say flux, flix, REST controller, and we could return, we could say get mapping movies and create an endpoint that returns a flux of movies, and that will work, right? This is going to be fine. This would work if we wanted to do that, but instead, let's look at the newer sort of an option, another option inside of a Spring Web Flux called functional reactive endpoints. And I like this style of building APIs. You don't have to use either one. Both are supported, and there will be for a long time to come. But the difference here with the functional reactive endpoints is that you centralize the configuration about the actions with the actions, right? And it's very similar to, for example, Sinatra in the Ruby world. It's very similar to Spark Java or to Scalatra, right? Lots of good options that look very similar to this. So what we're going to do is we're going to create a bean that defines an object of type router function that returns question mark. And so we're just going to return a definition of an object that returns routes, right? So router functions dot route request predicate dot get. So what we're doing is we're going to say, let's create a movies URL. And then here, we're going to have to provide a new handler function that returns a value. Right? So here, the mapping is specified here. Then we have a callback. And this, of course, is a natural fit for Lambda. So we could write it like that. Now, I could do that, but I'm a big fan of just having my handlers right next to the router. I don't want to have it all inline. It gets a little hard to parse and hard to test. So I create a little handler object.
Clean that up.
Yeah, clean it up a little bit. And so here we go. We're going to say flix handler, right? This is just a component. It's just a component that's going to satisfy the Lambda constraint here, the contract. So we're going to grab this, put that there, okay? And our job is just to return a mono of server response given a request for server request, right? So there's this public. So we're going to say we want to have an endpoint that handles the all request. We want to have an endpoint that does the by ID, and we want to have another one for the events, right? The cross the streams. So cross the streams handler by ID. Okay. So let's look at how we build this. We can use the service that Mark just put together for us to do all the hard work, right? So we're going to use that. We're going to inject it into the constructor. There we are, and we're going to say ffs dot by ID, passing in the ID coming in from the request. So let's go back to our configuration here. Inject this handler. The handler is called flix handler. So we're going to inject this as a component handler. And we can just delegate now. We can use method delegation, method references, a nice feature that only the most modern of modern languages have. Languages like C and C++, BASIC, JavaScript, Python, Erlang, COBOL, Go, Ruby, Haskell, JavaScript. It's not a language. I can't do it. I won't. So only the most modern of modern languages have this feature. So as Java champions, I'm very happy that we can now talk about this feature. So request predicates dot get movies ID, right? So here's that handler by ID, and route request predicates dot get movies ID events handler across the streams, right? Look okay to you?
Nice. Yep.
Okay, so there's that. And of course, this could be a little bit simpler by using static imports for the method, the predicate there, right? So we can actually get this down to almost trivial levels, and it becomes very easy to say, okay, here's the route, here's the handler, and we can test this very simply. So now let's go back to our implementation. We're going to say we want the request path variable called ID, and we're going to use that and pass it to this ID method. So our job now is to return a server response dot OK, and we're going to specify that the body is provided by this method here, and the body is going to return a single movie, isn't it? So I'm going to tell the Spring WebFlux API that it's going to take this data and it's going to convert it, kind of like the HTTP message converters in Spring MVC proper, into a JSON output of movie. Here, this one's even simpler. Here we're going to say server response dot OK dot body, and then we just say give us everything, right? All. And we're going to send a collection of movie classes back. And again, this is important to do because, remember, this isn't your traditional JSON. We're not going to use JSON and load the whole document and wait for the end of file and then send it back. So we need to tell the server side how to frame individual messages. We can't do the whole document. This could potentially have 1 billion records. So we can't load it all. We can't do select all, right? So this gives it a chance to be more efficient and to do message framing. Same thing for XML stanzas, right? We need to give it that opportunity. Now, this one's a little bit more involved, isn't it? So we're going to say server response.ok.body ffs.cross the streams, passing in the path variable here called ID. But we're going to send back a collection of movie events. And this movie event stream may persist forever, right? It goes on and on and on, like our talks, just endless. You know? So we need to signal to the client not to expect to get the whole response before it starts processing it. In JSON or REST, traditional REST and XML, it's going to say, okay, I'll wait for EOF, end of file, then I'll go back and turn it into an object that the client can use. But here, we need to tell it not to wait, that this is not going to have an end. It's an endless thing. So we can use WebSockets. That's certainly one way, but that's bidirectional, and that's certainly an option. For our purposes, we can just use server send events. Right? Server send events are a unidirectional protocol, and they tell the client that this data could continue ad infinitum forever and ever.
Like our talks.
And ever, right? So there's this. Run. I have forgotten the keys. Whatever, run.
Control R.
Control R. Command R?
Control R.
Control R. I'm scared. Okay, let's try this. So we've got our thing here. Curl HTTP localhost 8080
/movies
/movies. That looks okay. There we are. Yeah. Now let's get a single one. So we'll get the meet the fluxers, right? Copy that ID. Paste. Uh-oh. Did I do that wrong? Path variable ID, path variable ID. Movies. By ID. Okay. No path variable named that available. Oh, Santa Maria. Thank you.
So we.
Thank you, my mob programmers. Control R. Okay. So
should work a little better.
Take two, yeah. Here we go. Here's the meet the fluxers, new ID. Grab that. Then go one level down. Okay, there's our single record, right? So
up arrow.
Up arrow. How do I clear?
Oh, see,
there. See. Okay, so there's that one record. Now let's get the events, right? And if we've ever, look at that. Data framing, not bad. Okay, I think we're missing. It'd be hand wavy if we were to stop right here. So we're going to do one more thing in 5 minutes, and it's going to be great. 5 minutes is I think enough for us to do one last thing. We're going to build a client to talk to this service, right? And when I say we, I mean Mark.
Me.
It's him.
Yeah, we tagged. You probably didn't notice it happened so fast, but we tagged. So, okay. We're going to create a reactive web client because, again, this is really great on the back end, but really to take full advantage all the way throughout, consumer, all the way to the data store, assuming, Mongo works. We need a fully reactive stack. So we're going to create a reactive client. Let's go ahead and save that.
Now remember, all the interesting stuff is still happening on the back end and the server side, but we still want a client that does the right thing in the front. It's a client. It's not very interesting, but it's got to be reactive as well. So we want reactivity on both sides, but we want the interesting business logic on the back end. Client in the front. Spring Webflux in the back end. Call that the reactive mullet, right?
Wow. OK, I wouldn't have called it that, but
okay.
Yeah, that's fine. OK, I'm going to cheat a little bit to speed things up. I'm going to bring over our domain objects here. Yeah, so we should be good there. And go back to there, just to speed things along a little bit. And of course, we don't have to
again, we don't ever copy and paste.
No.
It's not a good idea, except when we do it.
Yes.
And even then, it is to be shamed.
Don't try this at home. We don't usually do this at home either. But let's speed things along.
I do.
So we have, you do?
I do.
True confessions. This isn't being recorded, right? Good thing. OK.
So, I did it once in college.
Did you inhale?
Copied and pasted.
OK.
God.
All right. OK, so what we're going to do is first grab hold of a web client. We're going to create a reactive web client. That will work.
Now hold on a tick. I noticed that's not the same thing I was expecting you to use.
What really?
What would we have used before?
This, right?
In Spring up till now. What's the
Oh, I see what you're saying.
Yeah.
Gosh, I didn't get the script ahead of time. REST template.
Right.
Yeah, but that has a small problem,
What's
right?
that?
It's non-reactive.
I see, okay.
Yeah, so again, if we're going to do this right, let's go all the way.
And it is a 10-year-old client, right? So this actually, this web client is simpler, it has a builder API.
We need turtles, reactive turtles,
Yes.
all the way down. So let's start off. You don't have to do this. I just find it kind of helpful, kind of nice. So I'm going to preload our address, start with our foundational URL for our web client. And then let's also just create a command line runner bean. Let's call it demo, and we'll inject our web client. So here we go, off to the races, right? And we'll implement our single abstract method so we can get started quickly, easily. So how would we like to do this? Let's see. So let's do a client.get, right?
Yeah.
.uri, and since we aren't adding anything to our base URL to start with, we'll just leave it at that. And we'll retrieve that, and let's convert that. Let's see, to a body to Flux, right?
Yep.
And we're going to convert this to movies. So we're hitting our main movie endpoint. We're getting back all of our movies. And that's a good start, but let's filter things just a little bit so we can bring this down to a manageable level. So let's filter this out to, let's see, movie.getTitle equals ignore case. What was one of them?
Silence of the Lambs. Let's go back.
Okay,
Copy
good
this, paste.
point. Yeah, let's copy paste this.
But again, never do this.
No, this never works. Silence of the Lambdas, right? So let's bring this over. And there we go. Hooray. So that should work, right? So now let's flat map that thing, right?
So we have a record which has this ID, which we can then use to load its events, right?
Yeah. So now let's hit the client again, and let's do another get. I wish it would indent for me. Gosh, wouldn't that be a feature? And we're going to, let's see, we're going to Uri. So let's add on to this here. Let's add our ID, right?
Yeah.
And get our events. And let's see, let's do our movie.getID so we can inject that ID into that.
Yeah.
So let's see, now let's do our retrieve. Yep. Come on. Body to Flux. Now this time we're going to convert this to movie events.
Not mouse events.
No, movie events.
Okay,
yeah,
good.
we got the right one. I typoed once, and he's never let me forget it. So, okay, so now we're converting this to a Flux.
We've got that. Now we just want to print it out, right?
Yeah. So
You've got an extra parenthesis, I think, there.
Let's see. Hold on. This is not.
Seems legit.
Yeah, it seems legit. Okay.
So subscribe.
So now we actually should probably do a flat map, right?
Yeah. Oh yeah.
Oh, let's see. How do we want to do this?
I think you can just return it, right? It'll give you a
Yeah,
flux
we
of,
should. So now if I do this
subscribe
and
to the outer thing.
oops. Yep, there we go. Dot
no, one level
subscribe.
down.
Yep, no, this should be right. Right?
Yeah, okay, there we
So
go.
we subscribe,
Yeah.
and let's just output it. Pringles, yeah, I'm hungry too. So now that should work if we get rid of this and we get rid of this. And of course, I forgot the semicolon.
Is this in Kotlin?
Sadly, no. Okay, so if we have no typos,
Come on.
let's try this, see what happens.
So we're doing a dependent call here. This is really convenient. Zoom in.
Look, look,
Zoom in.
it even works. Oh,
There we are. So we're calling values, returning them in a potentially unlimited stream. The client's never going to load all. It's not going to exceed its buffer in the client. This is different from the REST template, which would have tried to load all in the same thing and fail. We're using server-side events. We could use WebSockets. We're using REST, but it's all the same kind of thing. Whereas if you're doing Spring MVC proper, you would have done all sorts of gymnastics to say to the Spring MVC controller, this is an asynchronous stream of values versus this is just an object you should try and convert. It's all just fluxes and publishers and monos, so very convenient. Now, we've just looked at a few things here today. We looked at data access. We looked at Spring Boot. We looked at Spring Web Flux. We looked at functional reactive endpoints. We could have looked at Spring Security. Right? Spring Security has now newfound reactive support. Spring Boot 2.0 will be due this December. It'll have end-to-end sort of integration for Spring Web Flux and Spring 5. You'll see Spring, the reactive support in Spring percolate into different projects, including Spring Cloud shortly thereafter. Spring Data has already got support. So you're going to see this, in the next 12 months, you'll see this reactive support get sort of baked into every layer of the cake.
but don't wait. The bits are out there now. The code is out there now, so grab it and play with it.
And what is that code again, my friend?
What code?
Where's the code that they can try for this?
Oh man, you want me to bring that back? Okay, so let's see.
And in the meantime, are there any questions? Did we just explain it that well?
Just stun the silence.
Simple, right? It was.
And there it is.
All right. Thank you, Spring Days. Thank you,
Thanks so
Chicago.
much.
It was so much fun.